All right, so we're going to go over the Unit 1 pre-assessments. So let's start with number 1. So number 1 says, fill in the blanks to continue the patterns. So this is just straight up pattern recognition. Part A looks like we are going up by 3s. So the next two, this should be 12, and this should be 15. Okay. Part B, it looks like we're starting with 3 again, but now instead of adding 3 every time, now we're multiplying by 2 every time. 3 times 2 is 6, times 2 is 12. 12 times 2 is 24. And then 24 times 2 is 48. Part C, if we look at these two here, it looks like we're going up by 4s, because 9 plus 4 is 13. So 1 plus 4 is 5. 5 plus 4 is 9. 9 plus 4 is 13. 13 plus 4 is 17. Okay. And then lastly, part D. It looks like we are dividing by 2. Okay. So we can think of it as dividing by 2, or we can think of it as multiplying by a half. It's the same thing. 128 divided by 2 is 64. 128, half of 128 is 64. So if we keep doing that, half of 128 is 64. Half of 64 is 32. Half of 32 is 16. And then half of 16 is 8. All right, and that is it for number 1. Okay, let's look at number 2. Okay. Use the function f of x equals negative 3x plus 7 to answer the questions. So what is f of 0? So this is a review of function notation. And if you forgot from last year or from Algebra 1, whatever number is inside the parentheses, that is the number that you plug in for x. So for part A, I'm going to plug in 0 for x. Part B, what is f of 1/3? I'm going to plug in 1/3 for x, so on and so forth. So let's do that. So for part A, f of 0, I'm going to replace x with 0. Okay. And then calculate the answer. So negative 3 times 0 is 0. 0 plus 7 is 7. So part A, f of 0 equals 7. Part B, f of 1/3. So I'm going to do the same thing, except now I'm going to replace x with 1/3 and calculate. So don't be afraid to use a calculator if you need to. So negative 3 times 1/3 is negative 1. Okay, negative 1 plus 7 equals 6. So f of 1/3 equals 6. Okay. Let's go to part C. F of negative 5. All right, so we're going to replace x now with negative 5. So negative 3 times x plus 7. So negative 3 times negative 5, negative times a negative, that's a positive 15. Plus 7 is 22. So part C, the answer is 22. Okay. And lastly, part D, what is x when f of x equals negative 20? So hopefully you'll notice the difference between this one and the others. Okay. The others give you the value of x. Okay, in A, x is 0. In part B, x is 1/3. In part C, x is negative 5. Okay, and then you calculate the answer. Part D, they're telling us the opposite. They're asking us to figure out what value of x you plug in to get an answer of negative 20. So in part D, they're doing the reverse. They're telling us that the answer is negative 20. And they are asking us what value of x do we need to plug in to get an answer of negative 20. Okay, so essentially what we need to do is we need to create an equation. So we need to figure out negative 3x plus 7. What value of x is going to give us an answer of negative 20? So I need to take that equation and solve for x. Okay, so the first thing I'm going to do, okay, is I'm going to subtract 7 from both sides. Okay, this will cancel. So negative 20 minus 7, that's going to be a negative 27. And then I'm going to divide both sides by negative 3. Okay. Okay, and then I'll do negative 27 divided by negative 3. That's a negative divided by a negative. That's going to give me a positive 9. So x in this case equals positive 9. So to answer the question, what is x when f of x equals negative 20? X is equal to 9. And that is it for number 2. Okay. Number 3. All right, a city bus charges 25 cents per ride if you first purchase the $10 discount card. Let B of n be the total cost in dollars. Let B of n be the total cost in dollars of taking n rides on the bus. So before we actually answer the question, it's first important that we understand what this stuff up here is saying. Okay. So the $10 discount card, okay, that you pay before you even take a ride. Okay, so you're going to pay that $10 is kind of a one-time fee. You pay the $10, and then after you pay the initial $10, you're going to pay 25 cents per ride. So for part A, complete the table for the function B for several inputs. So before you've taken any rides, so when you've taken 0 rides, you've paid that $10. Okay. If you've taken 2 rides on the bus, okay, if we calculate this, you've paid the $10 initial fee plus 25 cents for 25 cents times 2 rides. So you've paid an extra 50 cents. Okay, 25 cents times 2 is 50 cents. So in total, after 2 rides, you've paid $10.50. Okay, the $10 for the initial cost of the card plus 25 cents times 2. Okay. For the next one, okay, if I've taken 4 rides, okay, 4 rides times 25 cents per ride, that's an extra $1. So I paid the $10 plus an extra $1. So I've paid $11 total. Okay, and lastly, if I've taken 10 rides, so 25 cents times 10 rides, okay, use a calculator if you need to, but 25 cents times 10 rides is $2.50. So I'm paying $10 plus the extra $2.50 for a total of $12.50. Okay. What Part B is asking us to do is essentially graph these points. So I'm going to quickly do that on here. So at 0 rides, I've paid a total of $10. At 2 rides, I've paid a total of $10.50. I'm going to go in between there. 4 rides, I've paid $11. And at 10 rides, I've paid $12.50. And if I connect the dots here, hopefully you notice, okay, besides my horrible artwork here, it should be a linear graph. What do I mean by linear? It should be a straight line. Okay, and the graph is relatively straight. Okay, so that is our graph. Part C, which is down here, write an equation for b as a function of n using function notation. So to do part C, I'm going to do that up here. We need to quickly review, hopefully you remember this from Algebra 1 and geometry, okay, for a linear graph, okay, for a graph that is a straight line, we use slope-intercept form. So to create the equation, we need 2 values. We need our slope, which is the m value, okay. In this case, the slope, excuse me, the slope is what you go up by each time. Okay. The b value, okay, this is what we call the Y-intercept. Okay. In this context, the Y-intercept is your starting value. Okay, our starting value, or sometimes you'll hear me refer to it as the initial value. Okay, so they're all referred to as that. So if we go back to the problem here, okay, your initial value in this case is the $10 because that's what you lay out initially to buy the discount card. And then the slope in this case is going to be 25 cents, 0.25, because that is what you go up by each time. Each time you take a ride, you pay an additional 25 cents. So to put it all together, okay, if we put it all together, our equation is going to be y equals 0.25x plus 10. Okay, if we put that all together and plug in the appropriate numbers, we end up with 0.25x plus 10. That is the equation of the graph from Part B. Okay, and that is it for number 3. Okay, let's go to number 4 now. Okay. Number 4, select all expressions that are equivalent to this expression right here. Okay, let's pull up the Google drawing so I can write on this. Okay, so we want all the expressions that are equivalent to this one here. Okay, if we count, it's 2 multiplied by itself 1, 2, 3, 4, 5, 6 times. Okay, so this is equivalent to 2 to the 6th power. Okay, so A is one of the solutions that we know of. Okay. If I actually multiply this out, okay, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So the answer is 64. So we can actually go through all of these and figure out which ones are equal to 64. We already know A is an answer. Okay. Part B, 2 times 6 is 12. So B is out. Okay. This one here, if we use our exponent rules, okay, by multiplying those exponents together, I end up with 2 to the 6th power, which we already figured out is 64. So C is an answer. Okay. D, 2 cubed plus 2 cubed. Okay, 2 cubed is 2 times 2 times 2. 2 times 2 times 2 is 8. So this is equivalent to 8 plus 8. 8 plus 8 is not 64. So D is out. E, 2 squared plus 2 squared plus 2 squared. So 2 squared is 2 times 2, that's 4. So this is really 4 plus 4 plus 4. Is 4 plus 4 plus 4 equal to 64? Nope. Okay. F, 6 squared. 6 squared is 6 times 6. Okay, that's equal to 36, not 64. So that's out. Okay. 2 cubed times 2 cubed. We can think of this two ways. We can use our exponent rules. Okay, if you forgot, our exponent rules say when we multiply, we add the exponent. So this becomes 2 to the 6th power, which is equal to 64. Okay. Or you can think of this as 2 cubed. 2 times 2 times 2 we already know is 8. So this is really 8 times 8, which is also 64. So G is an answer. And if you look at H looks almost exactly the same as C, except the exponents are switched. Mathematically, are we allowed to, if we switch those exponents, do the answers remain the same? And the answer is yes. Because if I multiply these exponents, I still get 2 to the power of 6, which is 64. So in total, there are 4 answers, A, C, G, and H on number 4. What are we up to? Number 5. Number 5, here are 3 patterns with term 0 through term 4 listed. For each pattern, describe a way to produce a new term from the previous term. Now, before I answer this question, notice in the question here, notice it said term 0 through term 4. In math, when we talk about a sequence of numbers, a pattern of numbers, it may not seem quite obvious to you. It may seem like we should start with term 1, but the starting term, what we will always refer to as term 0, not term 1. So the first term of a sequence or a pattern of numbers is really term 0, not term 1. Now, to answer the question, describe a way to produce a new term from the previous term. So if we look at sequence A, it looks like we're adding 3 each time. So to produce a new term from the previous term, we take the previous term and we add 3. Okay. 5 plus 8 is 3, plus 3 is 11, so on and so forth. Part B, sequence B, it looks like, it looks like we're multiplying by 2. A half times 2 is 1, 1 times 2 is 2, 2 times 2 is 4, so on and so forth. So the pattern here is to take the previous term, multiply by 2. Okay. C is not quite as obvious. C is not quite as obvious. Okay. But there is still a pattern there. Okay. Notice if we look at the difference, it looks like we're adding 1 then we're adding 2. 0 plus 1 is 1. 1 plus 2 is 3. Then we're adding 3. Then we're adding 4. So the pattern is we add, but we don't add the same number. We add one more than we did previously. So we take the previous term and we add one more than you did previously. One more than you did previously. So in other words, if I was going to find the next term after 10, I would add one. So previously I added 4, so I would add one more than that. I would add 5. So the next term would be 15. And then I would add 6, one more than I did before. So 15 plus 6 is 21, so on and so forth. Okay, and that is it for number 5. Okay. Now we're up to number 6, and that is the last question. Okay, here is a graph of a pattern of numbers. Plot the next 3 points on the graph. So if we look at the pattern here, to me, it looks like we are adding, or excuse me, it looks like we have a linear graph again. It looks like a straight line. So if we look at the points here, it looks like we go from 2 to 5 to 8. So the pattern here is we're adding 3 every time. So term 0 is 2, term 1 is 5, term 2 is 8. So they gave us up to term 5. So term 6 is going to be, so term 5 was 17. So term 6 is going to be 3 more than that, which is 20. And then term 7 is going to be 23. And term 8 is going to be 26. Okay. So it's all based on our pattern of adding 3 every time. Okay. Part B, write an equation to represent or describe the pattern. So we're going to do the same thing that we did a couple of questions ago when we did the one with the rides, with the bus rides. Okay. So we're going to do our y equals mx plus b again. Okay. Now, if you look back at the bus rides question, which was number 3, okay, you might remember, okay, that the m value, that is the slope, that is what we're going up by in this time. In the bus ride question, we were going up by 25 cents per ride. In this case, we're going up by 3. So in this case, our m value is going to be 3 this time. So y equals 3x plus. Our b value is the y-intercept. That was our starting value. In this case, our starting value is down here. Okay, starting value of 2. So our b value in this case, let me change the color, is going to be 2. So our overall equation, okay, is y equals 3x plus 2. Again, I literally did the exact same thing I did on the bus ride question. Okay, so that is it for the pre-assessment. This pre-assessment you do not have to turn in to me. It's just a skills check. We will do one of these at the beginning of every unit. So I would save this pre-assessment. If you worked on it in your notes, save it as part of your notes. And then tomorrow we'll start new material from lesson 1 of unit 1.